Let's explore a really unsettling question. Why do systems that become more connected also seem to fail more completely?
We're all taught to believe that connection is strength, that linking things together is how you build resilience.
I mean, it makes sense, right? A web is always going to be stronger than a single thread. It feels like basic, fundamental common sense.
But what if that's wrong? What if the very thing you build for resilience, that connection, is actually a blueprint for a total, catastrophic collapse?
And here's the thing. This isn't some weird paradox. It's a signature. It's the sign of a hidden structural force that's always at work, just beneath the surface.
So, to really see what's going on, we have to start with the basic logic of connection itself. See, no system ever becomes complex by accident. Every single link, every connection starts out as a completely rational choice.
Think about it. Individual parts of any system, they connect to get better, right? To improve their own performance, to find a little more efficiency.
They connect so they can get access to what other parts have, to tap into new resources.
And maybe most importantly of all, they connect to increase their own local stability. They're just trying to build a small buffer for themselves against any little shocks that might come along.
Okay, let's make this physical. Imagine a bunch of independent wooden blocks just sitting there. Each one is its own separate world, totally responsible for itself. If you nudge one, well, nothing happens to the others. The shock just dies right there.
But now, watch this. One block makes what seems like a totally rational choice. It connects to another block with just a single string. And hey, this link is good for both of them. It offers a bit of support. It really does seem to make them both stronger. But that rational connection, it also creates something else, something completely unintended. It creates a pathway, and this is what we call the silent transmission.
So now imagine a small, localized disturbance happens. One of those blocks gets nudged. Now, in the old, unconnected system, this event would be, well, meaningless. It would just get absorbed and disappear.
But now, that little disturbance travels. The very same connection that was made for stability has just become a perfect conduit for instability. And this is where the rules of the system start to feel really strange, almost alien. Suddenly, cause and effect aren't proportional anymore. That same small nudge might do nothing, or it could trigger a complete avalanche. You just don't know.
It's this strange, unpredictable relationship between cause and effect that allows a tiny, tiny disturbance to escalate into what we see as a cascading failure.
See, in a cascading failure, the initial shock isn't really the main event. It's just the trigger. The failure doesn't stay put, it spreads. It actually hunts for pathways through those very same connections that were supposed to create strength.
And we've all seen this pattern, right? In these big events that feel so sudden and impossible to explain. You see it in financial contagion that just flashes across global markets, or those grid-wide blackouts that start with a single tree branch falling, or even supply chain disruptions that can ripple out from just one port and affect the entire world.
Let's go back to our blocks. By now, all those little rational connections have added up. The strings aren't just single lines anymore, they're a dense web. And so when one block finally falls, the strings don't catch it like a safety net. No, they all pull taut, instantly. They transmit the force to everything. And just like that, one failure becomes a total failure.
So what is actually happening here? What is this hidden force? Well, it operates at a very specific threshold, a kind of tipping point that we call the point of inversion. This is the exact moment when strength flips and becomes fragility.
Think about it. Early on, when you only have a few loose connections, the system is great at absorbing shocks. Stress just kind of dissipates. But as those connections multiply, as they get tighter and tighter, the system's whole function inverts. It stops being a shock absorber and becomes a shock amplifier.
It's a stark reality. Beyond a certain tipping point, those interconnections stop absorbing shocks, period. They amplify them. And that means the very structure you built for stability is now the thing that guarantees fragility. So the system gets to the state where its own connections have become its single greatest vulnerability. It's not a collection of independent parts anymore. It's one single brittle entity. And in that state, the failure of any one component becomes a direct threat to all of them.
And this leads to the final stage, the irreversible state. It's what we call the logic of lock-in. So you might be asking, well, why can't the system just disconnect? Why can't it go back to being safer?
It's because those connections, the ones made for all the right rational reasons, they've created dependency. The components literally can't function on their own anymore. If you try to sever a connection now, well, that act alone would cause the very collapse everyone is terrified of. The structure is completely locked in. There's no way out.
And this is what reveals the most unsettling truth of all. When the collapse finally does happen, it isn't a system failure.
It was the system's own internal logic, simply playing out to its one inevitable conclusion.
You have to understand, the system was never actually failing, not for a single moment.
That collapse wasn't an accident. It was the final, perfect expression of the system's own rules. It was just doing what it was built to do. It was following its structure.